thank you for a seat here today. This is an OTT. I will talk about splitting Next.js monolith with Docker and Copilot. My name is Jose Liendro, and I work in the architecture team here at Wacron, where we use this space to share knowledge and share ideas, tools that we discover, some patterns, experience. So we store all this information on our YouTube channel, and as well we have a knowledge base, and it has public access. So you feel free to ask to anything there, and leave any comments in case you want to give more information. And as well, please give us a like in case you like this content. So what I have today for you guys is my experience over this last month, where I faced like a situation with a client where they have a monolith and they created an application with Next.js, and they have a couple of problems, and they want to improve the performance, and they have some goals that want to achieve. So what we need to do, one part of the proposal was to split the application in components, so we have more benefits that we can talk during the call. So this was the start point where we start with this client. They have a Next.js application. They have like two main place stakeholders. They are like a web client, a web user, and a CLI process that ingest a lot of data into this application. And on the other hand, we have an RDS. So that was like the first where we start. And the client comes with some problems to solve. So they want to improve or extend the functionality, improve in special the performance, and the performance to process information. And they also want to understand how can they deploy their application in new AWS account or even in other cloud providers. As well, they want or they are open to change their current stack because they start working in a POC, and the POC start growing up, and then we arrive to this position where we need to think in the architecture schema in a different way. For example, one of the concrete requirements was to process a terabyte of data that we wanted hundreds of thousands of requests in a short period of time. So that was one of the features that we want to give to the system. And they are concerned about the data integrity, so they want to avoid to lose data in the network issues. And as well, they want to also consider how they can work locally in this new architecture that we can propose. So we need to think in a way how to mimic everything that we propose to them. So what we did is, what we did is to use some tools that we have and we were using as Docker Compose, Docker multi-stage. We will use the AWS cloud provider. So there we have a couple of patterns in the connections to the database that is a fan out strategy. So we added a queue before arriving to the database. As well, we put in dev containers for local deployment in Visual Code. We have the Copilot CLI in order to deploy infrastructure and to build the pipelines in order to deploy the new services. And we include as well libraries as Husky and Jest to include unit tests to the application, and as well as part of the tool that are the OTT itself, where we are getting and using new tools like every week. For example, Copilot, I took Copilot from Hermia's OTT. So then what I will show here is an extension of the previous OTT where we describe this Copilot tool, and as well as other OTTs that we have, and also it's a place where we are implementing partners' suggestions. Like in this case, this fan out strategy comes from, in this case, was a pattern that Marcelo Barrios was sharing to me when he was studying for the architecture exam in AWS. So here we will see how they can be implemented. So what we did is a couple of proposals. These are the schema are what we want to achieve. There are a lot of things to do. So one of the problems that we face is how can we arrive to more complex configuration on architectures from one single container. So what we did is to start with a first proposal, which is the proposal number 0, where what we want to do is to split the single container into at least 2 main containers. That could be the API and a consumer. That could be like this. Here on the left side, we will have the application, and what we did is to split it in 2 main containers that they are reusing the same Docker file image, but with a different process. So here we will have a producer on the left side, and on the right side, we will have a consumer. And what we did is to put here an SQS in order to create a kind of buffer before we insert data into the database layer. In the past, when I was working to other client and in a hot sale situation, we were scaling here we have a lot of process handling thousands of requests, but we started having some issues here in the database layer because the pool of connection are not enough to handle the amount of requests. So this pattern is trying to propose one option that could be to insert a queue where we can store all the requests to be done. So then a consumer will be processing that transactions smoothly to the database, and as well they can scale. So what we did as well is to create another consumer that will work as a dead letter queue in case, here if we go back a little bit, here if the queue can't send the message a couple of times, if the worker can consume that message, then we have a fallback queue that with name the dead letter queue that will process like the error message that could not be processed like more than 10 times, for example. So this was a proposal, and then we need to implement it. What we choose to implement the proposal is to use Copilot, since it has the main 2 capabilities to deploy infrastructure on one side, and from a second point of view, they solved how can then we deploy all these services. So the main strategy here was to reuse the same container image. So we have available all the, in this case, we are using Prisma, we have all the utils, the libraries, the models, and then we want to have like different process in the same and running like different functions. So to achieve this, no matter here, like the initial point from this work, the client was using NextJS app to process and handle all this information. So what we did is to create more entries here. Since NextJS has like a client and a server, what we need to do as a kind of hack is to introduce more entries and at the time to compile the application. So instead of having a single output as the server JS application, we can handle like different process. So in an analogy from Django, for example, this will work as commands. So we can then run commands to manage like different concerns, like for example, to execute cron jobs, or to, in this case, to run a consumer or a consumer DLQ, and we will have available all the code base that we already have for the server. Then what we also did is in the package JSON is to add these new scripts that will call these new entry points that we call it like the generic upload consumer. And we will have one for the consumer and the other one from the DLQ. And here you will see the two main difference where we have scripts for development and for production. So for development, what we have here is node mode instead of node. So we have the hot reloading capability, and as well we included the inspect instructions so we can debug using Visual Studio. And then we are using waiting on in order to once we have this file, then we run the node daemon to refresh the consumer. And then another tip that I want to share with you guys, in this case, we are using a Docker file that has like the multi-layer strategy. The main idea here is to reduce the size of the final Docker image. And during the experience, I need to debug some issues related to the consumer is having some troubles at the time to run the final process. So what I was doing, and I found pretty interesting, was to inspect all the layers as different containers. So with these instructions, you can build a Docker file pointing to a specific target. In this case, all these layers and targets point to the same Docker file, but they are different layers. In the first layer, we install all the dependencies. In the second layer, we build the final application, and then we run. And the last will be the runner that will execute the application with a few amount of files instead of having all the dependencies. But since I want to inspect how these layers looks like, what I did was to build the Docker file just for some of these targets. So then I can be attached to that layers and inspect how the layer looks like. And then that was pretty helpful to, in this case, understand what are the missing libraries that the consumers requires. So that as well was pretty useful to me. And then what we use like these two tools in order to run all the environment. We use for local development, we use Docker Compose, and as I said, for the public application, we are using Copilot. And these two tools they have like pretty correlated features. Starting from the YAML file that they are using to describe the infrastructure. So locally, as you should, Docker Compose has a set of services where we can describe what the image that they are using and different things. So in this case, we are seeing like the description of the consumer of the queue that we start talking for. And first of all, we are reusing the first container that we built from the API. So here, what we are doing is to point and use the image that we already built in another service, in this case from the API. And on the right side, we have something similar in Copilot. Here we have a manifest for the consumer. And what we are doing is to refer to the location of the image that we want to use that was built in a previous service. In the same way, we are running the script that we created previously, and we are calling through the package JSON, and we made it available through the next config file, which is this command. They are running yarn and generic upload consumer. And on the right side is the same. We are using the same image, but we are calling with this. And then locally for local development and test, what we can do is to use like replicas. So we can start several consumers. So we can mimic how the queues works with all this message. And we can set like environment variables, in this case, to enable or disable the queue behavior. So and on the right side, what we are doing with Copilot, instead of using like local environment variables, what we are doing is to use the secret manager. And in this way, we are ingesting these environment variables from the secret manager to this service that will be implemented as an ECS Fargate cluster. So in orange here, I select and I highlight two aspects of this service and that I found interesting. First, we are using the REM architecture platform since it has cheaper behavior and since our image can be built with this platform without issues. And second, we have here the description about the auto-scaling feature. So we can say like the amount of tasks that we want to assign for this service and the policies, they will be in use to scale the service. As for example, the percentage of usage of the CPU, the memory, or even in this case for the consumer, we don't have like policies related to the amount of request or the time duration of the request, since the worker doesn't have like open ports and listen ports. So they don't have like external connections. But for example, on the other hand, the API, since it has a load balancer, will use that other policies to be responsive to the amount of requests. And then here we can see how these logs, the application looks like when we are working with this ecosystem. On the left side, we have here Docker Compose running, where we can see all these consumer. We have the consumer number 1, number 3, and number 2, which they are started and ready to process message. As a side note, these consumers will take like 10 message, 10 message each consumer. And then in this case, request comes from to the API. And then one of the consumer process the message. And on the right side here, we have a CloudWatch group where we can inspect how the ECS is working. And so in a similar way, here we can see how the consumer is processing the information for a message that was received in the queue. So as we said, we are using Copilot to deploy the infrastructure and the pipeline. And as a quick refresh, Copilot is a CLI that offers us several things that are really awesome. What I used in this experience was the pipeline and the deploy. Deploy will be used to deploy infrastructure. So at the end, we will have like CloudFormation templates where we have all the description on how this service looks like. For example, the worker that we saw, we will have a queue, we will have auto-scaling policies. And on the other hand, the API will have a load balancer that will receive the connections. We will have that kind of translation. And then for pipeline, when the pipeline is executed, will be translated to code build pipelines and how do you say the AWS pipelines. We will see this later, but we will use these two services to deploy our infrastructure. In this case, we are using GitHub. So a connection was configured to get access from our repositories. And then as main coordinates, when we are working with Copilot, first we have an environment. The environment will be attached to an account. Then in the environment, we can have applications, and an application could be described as a set of services. So we will have, for example, an environment that we can name as tests. And in the environment, we can have an application that could be, in this case, the application that we are working on. And then as a services, we will have the API consumer from the DLQ in this particular example, but we can have other services as well. And then I could not test yet these add-ons, but as well, they mentioned that they have as well to provide storage for our services. I think one of the main ideas here related to Copilot is that they help us to deploy and create pipelines for, they are like more related to a container approach. And well, so that is regarding the Copilot. So when we use Copilot in this experience, as I mentioned, we will have an environment, or we define an environment which is test and is assigned to a region and to an account ID. So at the end, we will have CloudFormation template that could be deployed to different accounts. That was one of the requirements of our clients. Then we will have an application that we name it as proposal 0, phase 1. And we start creating these three services, the API, the consumer, and the consumer DLQ. The main difference between these two are like the API will have a load balancer web services. That means that we'll accept external requests from the outside world, and the consumer, on the other hand, we will live in a private network, and we won't have ports on listening mode. So that is like the main coordinates about what we did with Copilot. And when we are using the CLI, folder will be created in our projects or in a repository, and will look like this. We will have a folder where we have our services, in this case, the API, then the consumer DLQ. We will have a folder for all of our environments, and as well, we will have a folder for the pipelines. And in all these cases, we will have a YAML files where we describe how this service looks like. So these YAML files here, as you can see, they are named as manifest. And here I want to highlight some of the features that these services have. So in both cases, we will have the auto-scaling feature, but as we mentioned, for the API, we are considering the request amount, but the consumer, since they don't have external connections, we are not considering the request. Then for both, we are using REM platform because it's cheaper than x86 platform. And for both, we are ingesting the same variables from the secret manager, since they are using the same Docker file to execute. But the first one will build and we'll have the reference to our Docker file. But the second will use the image that was already created by the first service. Right. That is what I want to highlight. And if once we create our services, we can see in AWS that in the CloudFormation section, we will see all the resources that were assigned to each of these services. So for each service, we will have a CloudFormation stack where we can see a list of resources that they are in use. So in this red box, we will have the auto-scaling resources that were created by Copilot. And here, for example, I highlight for the API, the ones they are related to the load balancer behavior. And on the right side here, we can see the queue policy and the queue itself, that the queue that was created to, so in this case, we are creating a worker that is associated to a queue that is created through this CloudFormation template. So once we are creating a deployed worker, we will have all these resources created out of the box. And then when we go to our ECS service in AWS, we will see that the application will live as a cluster, and we will have like all the services all together. In this case, we have the API, the consumer, and the consumer DLQ. And for each of these services, we will have the amount of tasks that they are at that moment. And that will be the ones that they have this elastic behavior, and depends on the amount of requests or the CPU usage, for example. So this is the place where we can see how the services are implemented in AWS. And then regarding the deployment, so they translate the deployment pipeline using code pipeline and code build. So what they use is to create a like 3-stage, where first they attach our code base as to get the source. Then there's the code build when the image is created, all the image of all our services are created, and then we deploy all the changes in the CloudFormation templates. So if we go to code pipelines here, we will see how they looks like. First, we have attached some logic. So we relate our GitHub repository in this example and this experience, but we can link any other couple of other repositories here as well, or another type of sources. Then here it's interesting because when you inspect the manifest that they are in the pipeline, what the script does is to list all the services and they are looking for all the Docker files that we are using, and then they will build all together. In this case, we have just one single image that is related to the monolith that we start using, and then we will refresh our CloudFormation templates. So we have one for the API, one for the consumer, and one other for the consumer DLQ. All of them will use the same container, but with different process, as we mentioned. And basically, the consumers will have, for example, the SQS client from the AWS SDK, and the API will be the one that will produce the work to be done. Then I found interesting here, this is the target pricing. And as you can see, for x86, we have like higher cost that if we are using like the REM platform. And Windows, it has like the twice cost of the Linux x86. So since these differences, I choose to use the REM. But from a pricing perspective, if we are not needing or we are fault tolerant, we can use target spots that they are the cheapest, but they are limited to x86 architecture. We cannot use. I don't feel confident yet to use this kind of spot, but maybe or some behavior or something that they are not critical, we can use target spots that they are cheaper. And here we are seeing the cost explorer. So after the experience, we can see in this case all the services that we were using by day, and in BioLeap, we will see the cost associated to the Elastic Container Services. So we can see here how they are increasing over the time. We can as well keep an eye open to the cost related to these kind of tools that they are awesome and they are creating a lot of things, and as well they have this auto scaling feature. So it's something to consider. And before to arrive to the questions, I also want to share. Let me go back a little bit here in this implementation. During our experience, what we have here in the middle of the producer and the queue, we have an S3, and that is related to two things. First, the payloads that we need to handle they have like more than 1 megabyte, so we can store that information in the queue, since the message should have like a couple of kilobytes, 200 kilobytes in average. And so since that situation, what we did is to use an S3 bucket where we are storing these objects to be handled. And a good thing that we made is also to put some parameters as tags in the S3 objects. So once the queue receive a message, what they will receive is a link for an S3, and then the object itself will contain some tags, for example, some IDs that we need to use to process that payload. So we use as well that as a pattern here. As you can see here in the API, we are receiving data, and then we store that the payload in a history in an S3 bucket, and then the bucket will send an event to SQS In this case, we put an SNS since was one of the proposals from the pilot, but I think they're not totally required here. The important part is like we are storing bigger informations in a stream, and then when the consumer start processing the information, we'll just download the payload and use the tags from the S3 object that we created at the beginning. So that's it. This was the experience. It was pretty interesting for me, and well, a lot of things to share with you guys. I know that there are a lot of things, but I think the purpose of these kind of meetings is to share ideas on things that we did, small parts that we can reuse in our project. So, well, I think it has a lot of corners and benefits. So that's it. Anyone has some current feedback or questions? Sure.
None so far. My side, Diego. I don't know if Diego was going to ask something, but not on my side, Jose.
Really nice, OTT. Really deep. You went with all the explaining everything. I have a question related to the ARM platform. Which challenge did you face using ARM instead of x86 platform? So which challenge did you face, or the libraries are all compatible, or you need to do some, I don't know, hacks in order to make it work?
Well, in this particular case, I think I should start saying like I have an Apple M1 machine that has that architecture. So I try to use it because they are better for my chipset architecture. And then when we were working with the client Docker file, we are using Alpine, and in order to have like the smaller image possible, so we can deploy like small artifacts. And when we are doing this experience with Alpine, we saw that we can use like x86 or REM without issues. We didn't need to do any customization. They just work out of the box. We change the platform, the Docker files will just work. So that was one thing. So in case like we can change the platform without extra cost, we have the benefit to have like 25% less cost in our ECS. That's one thing. Then to deploy the ECS, it was pretty straightforward because we can just describe that we want to use the REM architecture, and the only detail could be in the pipelines. And because when we created the pipeline with Copilot, we need to do a small change in the pipeline because we need, during the execution of the pipeline, at some point a Copilot agent is used, and we need to use the code, the Copilot agent built by REM. That's one of the challenge that was in the pipeline, and it is not well documented. So it's like a recent fact that issue that they face. So that's it. I think the main start point there was to have like a Docker image that worked fine with my machine. Then I understood that they have some performance improvements, and as well they have like better cost performance in AWS.
Great, thanks.
Guys, so this is the end. Thank you to assist today, and see you on the next time.